So, now we have seen here energy band, and now see, if you take conductors, for conductors, like this is here the conduction band where the electrons are free and the valence electrons are here, and the conduction band and the valence band overlap here. So, this is your valence band and this is your conduction band, this is overlapping. In this case, your energy gap is approximately here 0. So, for conductors, energy band or the energy gap is approximately 0. Now, if we look at semiconductors, in semiconductors, conduction band is like this and valence band is here. VB stands for valence band and CB stands for conduction band. Energy required to make the electron jump from valence band to conduction band, it means to make the valence electron free for conduction, energy required is here approximately, that is less than 3 electron volt. That is for semiconductors, not for germanium or silicon only. Now, if you take insulators here, in case of insulators we can take, so if you have taken here, this is a conduction band and there is a valence band. So, this energy gap is greater than 3 electron volt. So, this is here for insulators. So, energy band diagram for these 3 types of the materials like conductor, insulators and semiconductors we have discussed. And now we will be discussing here basically the semiconductor like a germanium and silicon. So, in this case, semiconductors are of 2 types actually, which we have to discuss in this chapter. The first one is known as intrinsic semiconductor and second one is known as extrinsic semiconductor. So, now see here in intrinsic semiconductor, basically examples are germanium, or that you can say elemental, germanium or silicon. So, germanium and silicon are taken as intrinsic semiconductor, these are called the pure semiconductor. Extrinsic semiconductors are made here by mixing some impurities, that is they are also known as doped semiconductor. So, now we will discuss one by one, first the intrinsic one and then the extrinsic semiconductor.